want to move on to the panel session that we have this afternoon. This topic will be on energy efficiency and sustainability in wastewater treatment process. Our moderator today is Global Water Practice with Ricardo Nada Akbar, as well as I think we're joined by 2 panelists, I believe, if that's still 3 panelists. So today we have Dr. Tatia again from Taka Water Solutions, Sudhir from Jacobs, and I believe we have somebody from Yasir from Wilo, Middle East and North Africa. So please join the stage. Thank you.
Good afternoon, everyone. Great to have you all joining us today. So I'm Nada Abubakr. I lead Ricardo's water practice here in the UAE and in the broader Middle East region. Very excited to be moderating this panel session and a great line of panelists that we have today. Before we start and introducing everyone, just to set a bit of the scene in terms of the actual topic itself, we're here to talk about energy efficiency and sustainability in wastewater treatment processes. Why is this important? And just to add a bit of context, a facility treating roughly around 50,000 meter cubes of sewage per day typically would use around 11 million kilowatt hour per year. So that is enough electricity to power a small town of 1,000 homes. So this is quite a lot of energy usage by wastewater treatment, and that's why the topic of energy efficiency is very, very much important. On the greenhouse, the GHG emissions side of things, you're looking at 2 to 3% global emissions contributed by the wastewater treatment facilities. So this is equivalent to proper high, GHG emissions from industry like the aviation sector, but a lot of it is not talked about. It's a silent emitter, and that's why, again, both in energy efficiency and sustainability in this particular sector is very important to look at. So we've got a great lineup of speakers, as I mentioned. We've got Titia Dimes, Sustainability Manager from Taka Water Solutions. Great to have you on board, Titia. Mr. Sudhir Kumar, Technical Director of Jacobs, and Mr. Yasser Nagy from Wilo, Middle East. So we've got sustainability, we've got consultancy, and we've got innovation to help us give us a very holistic view of this very important topic. So over to you both, to everyone. Today, maybe you can just give a quick introduction before we get started.
Yeah, thank you very much for the introduction. So I'm actually in the region since 2008. I was working as consultant, and since 2022, I started to work with then ADSSC. And since we have changed the name to Sustainable Water Solutions to more sort of cater for our vision and our mission, but now since we're part of Taka, we're changed again our name to Taka Water Solutions, and our mandate is to collect all the wastewater from Abu Dhabi to treat it and to produce recycled water. And besides this, we're also having some opportunities beyond our borders of Abu Dhabi in the area of large-scale treatment plants in Uzbekistan, for example. Yeah, that's it in short.
Good afternoon, everyone. My name is Sudhir Kumar. I'm Technical Director Water with Jacobs. I'm in the region for last 20 years. I'm a water engineer, work on water and wastewater both sides. And overall, in the water industry for last 28 years. So very happy to be here, part of this panel discussion.
So good afternoon, everyone. My name is Yasser Nagy, and I'm the Regional Managing Director for Middle East and North Africa for Vilo. And I've been in the entire region for my entire life because I'm Egyptian, so I know the region inside and out. Of course, maybe not in the exact water sector, but I joined the water sector when I joined Vilo back 7 years ago. So I've been getting a lot of interesting information from Vilo, from the technology of the water in Vilo with pumping and pump systems. Maybe I'll talk later about Vilo and what it does later when we have the questions. Thank you very much.
Thank you all for the introductions. So wanted to help us set the context, Sudhir. I'm going to start with you if that's okay. In terms of helping us understand what are the key issues with wastewater treatment infrastructure, get us to understand that a bit more, just to set us off before we get into, the actual, some of the challenges and forward-looking aspect.
Yeah, sure. So, when we talk, I can see like in last 2 days, there were a lot of discussions earlier happen on various aspects of wastewater treatment, recycled water. So when we talk about wastewater treatment facilities, it's a highly CapEx and OpEx oriented. So if you look at overall life cycle, probably 40 to 50% of costs is in CapEx, and then another 50 to 60 goes in OpEx. And one of the key part of OpEx becomes energy consumption, which as you were giving some statistics earlier, so I would say like depending on the capacity of the plant and some other factors, the level of treatment and all, it could be 0.5 to 1.5 kilowatt per cubic meter of water you treat. So in current context, I would say some of the key challenges which I think authorities fail and overall facing day to day is, I would say, one of it is like energy consumption, high energy consumption and how you mitigate that. There are some regulatory aspects also in terms of the level of treatment are needed and associated impact. I think earlier Dr. Titya was mentioning when responding to one of the question on solid waste and the sludge side of it, and why I think currently it all goes from Water to the landfill, and why it is happening so, because it's unable to meet some of the regulatory need. So there are like these kind of regulations which some of it comes new, and you need to face that, and that's one of the challenge. Number of other challenges which I have seen is very interesting is related to future proofing. When we design any sewage treatment plant and then we look at 5 years down the line when it starts operating, we find almost in all cases different inputs than what it was designed for. It could be in terms of diurnal flow patterns, it could be in terms of the influent characteristics that was considered earlier. So that's again one of the challenge. Linked to the climate change, I would say there is another aspects into it. Although if we take example of UAE, there is a separate system, but during any rainy event you find that there is a lot more flow received at treatment facilities, and that creates another query on like whether the plant is future proof on that side or not. We talk about the carbon circular economy aspects into it. The current focus mostly goes on the pollutant removal. So if we add into it the angle of sustainability, then probably we need to think slightly differently. And I would say one of the last one is even on the regulatory side is that the regulatory requirements keep changing over the year, because more and more stringent regulations are coming up to tackle the unforeseen situations or the ever-changing environment. So then that also creates like how you make your infrastructure future-proof for these kind of changes.
Thanks, Sudhir. That gives us a very holistic view of some of the challenges that are faced in this context of energy efficiency and sustainability in wastewater. I want to move across to you, Dr. Titya. That applied knowledge that you have through working with Taqa Solutions, what are you currently, if you can share with us, what are you currently doing in that space of sustainability and energy efficiency in the context of wastewater?
Yeah, so maybe some of you have already seen also my colleague Mayang speaking about ESG. So we're actually supporting ESG from the sustainability department, but also with regards to like energy saving, we're ISO 50001 certified, which demands like a continuous improvement of your energy consumption. So you have to identify what are your highest, like the pumps and the blowers, they use most of the energy. What can you do to improve this over time? So also with respect to sustainability and carbon, we're past 2080 certified as well. So we keep track of our embedded and carbon and operational carbon every year, and we just have targets to sort of reduce this amount. So currently, the biosolids, they are actually contributing for 40% of our operational carbon, because if you send it to landfill, you have to account for methane will come from them, some sort of you store it for a long time, and this is 227 times more potent than CO2. So if you want to press it in CO2 equivalents, this will then contribute significantly. So that's why we're looking at, you know, alternative ways to use our biosolids in a more sensible way, and also prevent this to go to landfill. So currently, this has become part. There are two projects become merged. We had a project called Project Energy Optimization, which is focusing on the biggest plants that also produces biosolids, and a project that called Project Green before, and that was looking specifically at using our biosolids, but also our biogas. But now this is sort of shifted to this other project, and some very interesting options have been chosen now to further develop into a preliminary design. So this, in future, we will be able to meet our KPIs on energy reduction and carbon emission reductions.
Sounds like an exciting time to be at Talca Solutions in the context of sustainability. Thanks for sharing that, Dr. Titia. I want to move across to you, Yasser, if that's okay, to talk about innovation and technology. What are you currently seeing the impact that it has, particularly with digitalization and AI, and what impact it has in the context of energy efficiency and wastewater?
First, thank you so much. I'd like to first give a little bit glimpse of Velo. So Velo is 150 years old company with 17 production sites globally, and we have just integrated our extension in Dubai. We doubled our capacity. We have more than 500. We have a test bed that has more than 500 kilowatt of capacity of power, and around 9,000 square cubic meter per hour for submersible pumps. So that's considered to be one of the biggest in the region, as a matter of fact, Middle East and Africa. Having said that, coming to your question, it's important to maybe shed some light on the energy efficiency aspect. And when we're talking about pumps and mixers, for example, we're talking about a global consumption of electricity of around 10%. So that's huge. So to consider, this is why when my colleagues here are talking about energy efficiency when it comes to pumps and mixers and aeration, we're talking about a huge lump sum of energy, of electricity being consumed from those equipment. And for Velo, this is something that we take very seriously, and going to sustainability, this is where we decided on a global basis to utilize our sustainability strategy and making it as an overarching strategy, coordinating all the other corporate functional strategies, making sure that everything, that all the impact areas, the global mega trends that we're considering to be completely subordinated to our sustainability strategy. And to just give one example of the technologies that we have used is considering, for example, AI-driven control systems, which are in existing treatment plants, and they are mainly to monitor oxygen consumption. And when we utilize that, we have been able to save around 40% from the energy. So this is just one example. Another example, which I think is very vital, is to our core business, which is the pumps. So we have a smart sewage pump, which is using something called Nexus Intelligence. And in a nutshell, simply the amount of energy efficiency and the connectivity and the reliability of those pumps makes it to a large extent a winner, because when you talk about connectivity, which is important efficient right now to have real-time information being fed into a control system so that you can take corrective action, anti-clogging. All those aspects of reliability helps a lot in the energy saving and the electricity saving that we would like to accomplish. This is just a quick 2 examples.
All right, thank you, Yasser. So you've touched on some great examples, particularly Wilo, if I'm pronouncing Wilo, more German. So that's great, great context. I want to stay on the technology, but on implementing technology. So back to you, Dr. Titia. What are you seeing are some of the challenges with implementation of these technologies in the world of Taqa solutions and broadly as well?
Yeah, some of the, for like maybe Europeans, low-hanging fruit would be if you have a biogas, you will convert it into energy with CHP, what they also do in Jordan. We just heard they have a very good harvest of this. But if you look in this region, then the energy price is very low. So to be able to run your engines, it's often not economically feasible to do so, and it's then cheaper to buy it from the grid. So that is one big sort of challenge to overcome. Because from a carbon point of view, of course, it makes completely sense. If you have the biogas, it's better to burn it, recover your heat and recover your energy. So another one is also some frameworks are quite tight, some regulations. If you look at the Class A biosolids standards, they're actually a bit more relaxed than the ones that we have here in Abu Dhabi. So it's also, it imposes you have to have an additional treatment for your biosolids to be able to use it unrestrictedly in land, for example. And this will then, make an extra threshold to be able to go ahead. But another thing I just wanted to point out, also from a sustainability point of view, it's always better to use the recycled water over the desalinated water because, we use about maybe 0.65 kilowatt hour per cubic meter for treating wastewater. And this is, on average, our smaller plants will be a bit less efficient. Bigger plants will more go to 0.5, whereas for desalinated water from seawater, it's still about 3.5 kilowatt per cubic meter, and this is also with energy recovery. So there is challenges, and there is also a lot of opportunities.
Great, something for EWIC to take into consideration from Paul's discussion before. Thank you. No, that's great. Thank you, Dr. Titia. I want to jump across to you, Sudhir. You've touched on regulation a bit in your previous answer to that question, and keen to understand what are the challenges that you see in terms of balancing energy efficiency and overall performance with environmental compliance. How do you see that balance taking place?
I think one of the most important part of it, Dr. Titia already, covered, is that although the treatment plant is energy intensive, and when you compare it with the desalination plant where the energy consumption is like 3.5 kilowatt per cubic meter in comparison to 5.5 to 0.7 in wastewater treatment, which drives more towards recycled water. Right now, although energy reduction is linked to the carbon footprint, but there are not like regulatory drivers sometime on it, and it's a more kind of, I would say, stick and carrot, like altogether, incentives related aspects in the policies. So if energy is much cheaper from the grid, then the question goes as like how you drive that sustainability aspects to come up with solutions which is still probably on the dollar value may not be that viable. So that's, I would say, currently our regulatory standards are more focused and pushed on the performance aspects of recycled water, what degree you want to have, or the sludge side, production of sludge and what level of treatment. But I think add-on policies are needed on sustainability side also. If we look at the UAE aspects, UAE have a commitment of 2050 carbon neutral. So it can't be done by, one entity or so. It cascades down to all departments and all sectors to have their bit of share.
And there's also a new presidential decree saying that companies have to disclose their carbon emissions, or you get a big fine.
Okay, well, there's your stick. You do eventually need that to drive that sort of good initiatives to actually take place.
I want to give one more example. I mean, on the sludge side, as Dr. Titya was earlier mentioning, that there are standards related to the treatment standard, and because we are unable to make it like unrestricted reuse, so it all goes to, like all the sludge produce goes to the landfill. Now just imagine if there is another decree or policy comes, like you cannot have any sludge going to the landfill. So then you need to come up with solutions.
Yeah, I think it's coming, you know?
Yes. So you need to come up with solutions. You don't have any choice. So you need to come up and implement the solution to avoid such situation.
All right, well, speaking of solutions, we've got Vilo in the room with, high German efficiency. So you've got a solution there, and I just gave you a plug, so I hopefully get a commission if for any sales made. But interested to understand, you've made some great claims on terms of your technology and the value that it brings. What are the barriers that you've seen in terms of uptake?
Well, I try to be politically correct as much as possible, but mainly the regulations. So I would put it in a very realistic form. So whenever there is a project, there is a budget for this project, and that budget is mainly driven by sometimes, or I would say the vast majority of the times, on old technologies, and hence the budgets are tied. When I forgot to mention that for our R&D, who are using around 4% on annual basis of our turnover, of our annual turnover on R&D. So we are developing, the technologies are there, but of course the technologies cost money. And when we're talking about technologies that are fresh, are new, a lot of investments are made, when we come to present them to the end users, to the authorities, we are extremely far away, regardless. And this is the question then comes to the long-term return on investment versus the short-term cost saving. And that is, I think, that's the core of everything that we're talking about. I mean, the systems are there, the technology is there, the mindset is there, but the budgets are not there. So this is one aspect. The second aspect, I would say, is also the resistance of change to the. Not the facility management as such, but the people who are working there. So the lack of familiarity with the new technologies versus what I know, what I'm confident, and I feel confident and, in my comfort zone, I know how to deal with this. And then this is a question of, are you as an end user or as a company who is or going to invest in this, are you willing to, for them, of course, for us it's risk-free because we guarantee that this is going to work. We have already been spending lots of money on making sure, and lots of tests to make sure that this is going to work. But for the end user, it's going to be, no, this is, I don't know, I'm afraid maybe the this AI technology-driven is not going to work, maybe something is going to happen, and then I'm not going to be able to work with it, and then, no, it's better to stick with what I know. So this is also something that, I mean, realistically, that happens. Maybe it's not being spoken of, but this is a fact of life, unfortunately. I'll give you just one simple example. For example, back to sustainability, maybe it's not 100% related to water, but I can tell you that we are investing, for instance, in hydrogen. So we have our own hydrogen power plant back in Germany. So we are climate neutral. The factory of 250 square meters is all covered, all the roof is covered with PVC photovoltaic cells, and this is fed into with our own, we invested in our own electrolyzers, and we have our own complete system with our own storage tank That's in Germany, in Dortmund, where the headquarters are. We want to replicate that here. And I can tell you later what sometimes we're having some obstacles to be able to replicate that here. So I'll keep it there.
So you're not just talking the talk, but you're walking it too. So that's great. Great to hear. So in wrapping up, I wanted each of you to, if that's okay, to share under a minute. What do you guys think the future looks like? So just some takeaways from today, from what we've gathered.
Yeah, well, how I like to see it is that we continue this collaboration and events, and that we also, have the courage to go into new technologies that we're a bit uncertain of, and to be able to do so, we need to start, R&D, have pilot project on our sites, and so then prove also that you have the product, like with example biochar, you can create a market, because the problem now a lot of times is, technically it's feasible, but then if you bring it to any investment committee, they will say, okay, what's the return on investment, what are your off-takers, and what are you going to do with it? And if you then say, yeah, well, this is a new technology, we don't know yet, there's no regulation in place for this, then very quickly it is the plug is pulled on it. So yeah, I would like to just collaborate with research institute companies, universities to make this happen, and so that we are in the time that these technologies are fully ready for implementation, that we can just start straight away.
Thank you, Dr. Titia. Sudhir?
I would just summarize on, because in previous panel discussions also, there were talk about technologies and use of technology, artificial intelligence, digital twins. So in wastewater treatment, why it is important is, like as I was highlighting earlier, that although when you design a plant, with certain parameters, you see a couple of years down the line, like it's not the same, it's varying. And then in that varying environment, how your selected equipments and process, functions and work, probably by utilizing these advanced technologies in terms of sensors, in terms of, having as a digital twin for predictive analysis and all, really help in optimizing your plant, from process efficiency point of view, as well as from energy consumptions and all. There are other aspects too, but I would say from the technology perspectives, like utilizing latest technology for process optimization is becoming a key.
Thank you, Sudhir. Yasir?
Well, I hope that there will be more incentives from the governments to make sure that the right regulations are also amended, updated. Of course, from our part, we try as much as possible to do seminars, have lots of meetings with the concerned people, with the authorities, with the municipalities, with the government, that can influence those regulations, because I don't think that there will be a leap forward unless those regulations are open and flexible enough to adopt those new technologies. So it's not a problem in technology. Technologies are there, whether ours or others. A lot of companies are inventing and investing in those kind of technologies driven towards sustainability and sustainable growth. But the problem here is we are always having this wall that the speed that the innovations are taking place are not, they're faster than the regulations in place to a large extent. And I think this is one of those aspects that if they're solved, then we'll probably see a lot of better results.
Excellent. I do agree, and there's some great examples from the finance sector and sandboxing that is taking place that allows technologies to operate under free regulation just for trialing and testing. So hopefully we can see that in the water sector a bit more. Thank you so much. I wanted to open up the floor for the audience. Any questions? Yeah.
Thank you, Nada and the team, for this engaging discussion. I know from the regulatory perspective, I am from Department of Energy, Recycle Water Senior Engineer. And to answer the question of Yasser Nagi and Sudhir, we already have got, and Dr. Tisha knows better than anybody else, that there is an incentive already being already there, and 15% reduction every year for the landfill reuse. If you are diverting that landfill. So we really appreciate to have Dhaka Water Solution to engage with many research institute or anyone to have that in place to have this landfill being diverted, rather than maybe the proposals that were coming in for bioincineration, all those things are going to get more GHG emissions. So we thought of it, so unless you cover that gap, it may be hard for the regulatory aspects over here to reach to this 2015 neutral aspect as well. So we really strongly recommend Dhaka Water Solutions to engage in with research institutes to come out and also use your expertise to manage that landfill. Thank you so much.
Yeah, thank you, Engineer Shelby.
Any other questions from the room?
I want to echo what you said. It was excellent discussion over the past half hour or so. It's Tim Constantine here from Jacobs, and we talked a lot about energy and how it impacts greenhouse gas emissions, especially here. Dr. Tisha, you noted the methane when you send it to the landfill, but I didn't hear anything, or maybe we can extend it here and talk about nitrous oxide emissions. When we do biological wastewater treatment, N2O we found in locations around the world that it can be a very high and a major contributor to the greenhouse gas footprint of a treatment facility. And sometimes it works against each other. You try to save energy by running at lower dissolved oxygen, and your nitrous oxide goes through the roof. So I'm curious if that has been in your facilities here and elsewhere. Have you been testing that out and seeing what the impact is?
Yeah, we're not testing it, but we calculated it. But the thing is, for us, we don't have any standards for nitrogen because we're going to use it for irrigation. So a lot of our plants, they don't have denitrification. So it happens, simultaneously, but it's not really that we have anoxic zones as such. But we do calculate it, and I think in future we may, also measure it.
It might be good to measure it because even through nitrification, which you can't stop here with this wastewater temperature, you can get that nitrous oxide emission just from the aerobic pathway. Something to think about.
Thank you. I think we're on time. Yes? All right, cool. Thank you for your time today, panelists, and everyone for your attention. Appreciate it. Thank you.